Today I'm actually in Pittsburgh, PA at Aqueon Energy, where I've had the privilege of using this Haas VF-2 machining center. I'm going to go through pretty much the basics of how to use this machine, how to set up a tool, how to set your work coordinates, and how to start a program. So let's get to it. All right, these are the things we're going to need in order to do this project. First and foremost, safety glasses. I mean, I didn't realize until I got laser correction that glasses are super helpful, and you know, the last thing you want is a metal chip or something to fly and hit you in the eye, and then you can't see, and then, you know, where are you then? So definitely wear your safety glasses. Try not to wear any loose-fitting clothing or jewelry or long hair. I know I'm breaking some of those rules, but you know, just be vigilant. These machines have an insane amount of power, and they'll smash you and rip you to shreds if you're not careful. So, to do all this setup process, the things we're going to need are. This is just some basic, simple green diluted degreaser. You're going to need a height gauge. This is a Mitutoyo digital. You can also use a dial height gauge. You're going to need a tool that you want to use on machining your part, an edge finder, the actual stock that you're going to use to machine, rag, set of parallels, and then there's two options for how we set the tool height, and I'm going to show you both. One is this fancy tool height gauge, which is basically a 4-inch calibrated press gauge here. Or you can use a 1, 2, 3 block and a dowel. In this case, we have a 400,000th thick dowel. So those are all the stuff we're going to do. And now go into, you know, actually using the machine. All right, first things first, you want to make sure the main power is on. This is a 3-phase unit, so this has a bus bar, and you can see that the little switch is in the on position. And then hopefully your CNC doesn't have its door just hanging out like this one, but this is the back control unit, and there's all sorts of fan stuff inside. But what you're concerned with is this breaker right here, which is usually accessible with this big knob on the back. This is on right now. I'll turn it off for demonstration purposes. This would be off. So first thing you want to do when you start up your machine, make sure the main power is on, and then turn the breaker on. Don't touch anything in here because it's gonna kill you. All right, this is your CNC control center. Basically, you have power off, power on, the spindle load gauge, emergency off, which pushes, and then you twist it to turn it back on. This is a general use handle, which we'll use when we set up the different tools and stuff. Cycle start starts your program, and cycle stop stops your program. And then this whole keyboard is what we'll use to control, and the display shows you what's happening. So let's start the machine up. Press power on. You'll hear that relay click on, and the machine will turn on. So that's the old program that I used to say. Now when you see this says alarm down here, you want to go down and press alarm messages. And that will bring up what the alarm is. Now this indicates that the servos are off because the machine was turned off. So in order to clear the alarms, you're going to press the reset button. Now it says no alarm. Okay, so the machine is on. Clear the alarms. Now the first thing you want to do after you do that is you want to do this power up restart, which is right here next to the reset button. What this is going to do is it's going to home the X, Y, and Z axes and put you in a position to do what you need to do. If you don't do this and you try to move around, for example, I'll try to move somewhere by pressing handle jog and feed, it's going to say something like no 0x because it doesn't know where it is in space, and that's what I'm going to explain in a minute. The first thing you need to do is you need to tell the tool holder of the CNC machine, where am I oriented in space, so that you can reference that coordinate system. So we'll press power up, restart, and you'll see this start to move. All right, so now the machine has zeroed itself. Now what that means is this face under here, where the tool goes, is at a 0 point in the Z direction, a 0 point in the X direction, and a 0 point in the Y direction. So this is 0, 0, 0 in a coordinate system. And everything else that we do from there is going to be referenced off this. So when you go down, that's going to be negative, below the Z plane here. So a lot of these dimensions are going to be negative. Similarly, when we go this way is negative in the X direction. And this way is negative in the Y direction. So that's important to remember. When you turn the machine on and it homes itself, it's going to be at 0, 0, 0 X, Y, and Z coordinates. So now that we've homed the machine, we'll start by setting our work coordinate system. Okay, now that we've zeroed the machine, it's time to set our work coordinate system. Now, just like I was saying that the 0, 0, 0 is up here for the machine coordinate system, what you're going to want to do is set a 0, 0, 0 for your workpiece, because often you'll have an origin in your machine diagram, in your part diagrams, and that's what we're going to define now. So this has a fancy little stopper on here, and basically we're going to figure out that our work is off this face, and this vise is turned around, so this will always be the 0 in the Y direction, and this will be the 0 in the X direction. And we'll deal with setting the Z a little bit later. So in order to do this, we're going to have to put our workpiece and get it ready for edge finding. So what I'm going to do is I'm going to clean off the inside of these vices, and then I'm going to put some parallels in the vices. And then I'm going to put the workpiece that I'm going to be machining in the vise. And finally, tighten it together, make sure it's against both these edges. Alright, so now I have the piece that I want to machine in the vise. And what we're going to do in order to set the work coordinate systems is use an edge finder to find the 0 on this face and the 0 on this face. And then we'll set our work offsets. So basically, how far from the machine origin is this face, and how far from the machine origin is this face. And then when we set our Z offset, it will be the tool offset to machinable surface. And I'll explain that when we set the tool offsets. But right now we're just going to be concerned with the X and the Y work offsets. Now, before we do that, I want to explain a couple more things about this machine. So, one thing that you're going to want to do when you're setting your offsets is move the head around. And in order to do that, you press handle jog and pick the increment you want to move in, and then the axis you want to move in. So if I want to move the bed in the X direction, I'd press handle jog, X axis, and then let's say 10 thousandths at a time. And then when I twist this, you'll see here, it moves it back and forth. Don't worry about the plus and minus for these axes. That's for something else. You can press either one. Both Y, plus Y and minus Y do the same thing for these purposes. So that's how you jog around. So the next thing that you'll need to know how to do is put a tool in. So this button right here, tool release, what it does is, you'll hear a sound in a second. That's the drawbar, the tool holder. So in order to do a tool change, you hold this button down, position this in the notches on the machine, and then release it, and that will suck it up in there. So for this work coordinate setting, we're going to use the edge finder tool, and that's going to end up going in tool slot 1 there when we put it away, when we do our tool change. So I'm going to put the edge finder in and be back in a moment. Alright, so now we have an edge finder in the machine. So all it is now is a matter of jogging the edge finder down to these edges, moving it in to see when the edge finder moves over, and then setting our work coordinates. Now, in order to turn the spindle on so that you can spin it and use the edge finder, what we're going to do is we're going to go to the MDI DNC button, which is going to bring up an editable program. And now what we want to do is we want to set the speed to 1,000 and turn the spindle on. So that's going to be S 1000, alter, M3, alter. So you can use this alter button to alter the existing G code there. Alright, so now when we press cycle start, this is going to turn the spindle on at 1,000 RPM. And there it goes. Alright, so then it's just, I'm not going to show you the edge finding process, but it's just like with a manual mill. We'll go to handle jog, and we'll jog it in the Y-axis here. The X-axis, and the Z-axis. And then eventually we'll want to press this 1,000th increment button here. And that'll allow us to jog in 1/1000th of an inch increments, which you can barely see here, until the edge finder clicks. So now I'm just jogging the edge finder over in 1/1000th at a time. And when it finds the edge, it will slide to the side. There it goes. We're going to back it off and see it happen again. Alright, now that I've found the edge, I can turn the machine off, press reset. Now that I've found that edge and compensated for the 100 thou distance between the edge of the edge finder and the center of the edge finder, I jogged it over an inch when it was out of the way. You can also just use math, but I always like to see the tool go to where I want it to be. Now you're going to set your work offset. So you go into this offset button menu here and press it again, and this shows you your work offset, X, Y, and Z. And for G54, which is our first work coordinate system, our main work coordinate system, we just set the X direction. So you're going to go down to the X, and you're going to say part 0 set. And that imperceptibly changed because I had already set my 0. Now you'll do the same thing for the Y, and then you have your X and Y set on your work coordinate system. So the next thing we're going to do is we're going to put in a tool and set the tool height offset. Alright, this is the tool that we're going to be putting in. Let's say we wanted to mill our material with this 3/4 inch end mill. Now, what the tool offset is it's the distance offset the end of the tool is from that Z0. Because remember, the bottom of this tool rest is where the Z plane starts. And so if we know the distance from here to the bottom of the tool, then the machine will know where the bottom of the tool is relative to its Z. And so there's two ways to do that, which will make a lot more sense when I do it. Basically, our goal here is to pick a surface on the bed that will be our height reference surface. So what I usually do is I use this back of the vise here. So I'm going to say that I want to find out the tool height offset from this reference surface, and I will use this reference surface to set my Z offset later. So all we need to worry about now is setting the tool height offset to this surface. All right, hold it right there. This is Jason from the future, and this is not how I set my Z height offset today. I don't know what I was thinking back then when it would be so simple to just set the bed of the vise, the very bottom of the vise, as the Z0, and then use the parallel thickness to compensate. Basically, if you know how thick your parallels are and how thick your stock is, you can just add those two together and get from the bed of the vise to the top of the stock if you set your origin point to the top of the stock. Or better yet, set your origin point to the bottom of the stock, and then all you need to do is add the very accurate parallel thickness. So I've learned a bit since this video is made. Throughout the rest of the video, you'll see me do this strange thing with a height gauge. And I would say that the way to really do this is to zero to the bed of the vise, then add the thickness of your parallels to your Z offset. Well, back to my strange past. And there's two ways to do that. The way I'm not going to show you is with a 1-2-3 block and a dowel pin. You don't even have to use the 1-2-3 block, but it's nice to have some extra height in there to move your hands around. Basically, what we're going to do is you're going to have this 1-2-3 block on your reference surface. You're going to jog your tool down over top of it very, very, very slowly, and then you'll take your dowel and slide it until it just slides underneath the tool. You don't want to pull your tool down onto the dowel. You want to put your tool down until you can't get the dowel on, and then start backing it off until it just slides under. And so that will tell you that the bottom of your tool is 3 inches plus 400 thousandths, so 3.4 inches off your reference surface. Basically, what you need to do is you need to know an amount of distance from your reference surface. You can even, I wouldn't advise it, but you can even slide a small piece of paper underneath your tool on the reference surface, but that can get you into trouble because of the paper thickness, and you don't want to smash your tool into your vise and whatnot. An easier way to do it is with this fancy little thing. So this is a 4-inch calibrated tool height checker. Basically, the dimension of 4 inches is what you will want to know from your reference surface, and as the tool comes down on this, there it is. So that would be exactly 4 inches between the bottom of your tool and your reference surface. So let's put this on the reference surface and put the tool in. So here's the reference surface that I'm going to use, the back of the vise. Now I use that rag and degreaser to really clean this off and make sure there was no chips or anything that could mess this up. Now I'm going to put the tool height checker there, and I'll jog my tool down on top of it. Alright, before we get our tool height offset, we're obviously going to have to put a tool in the machine. And so in order to do that, like I said before, tool release will allow you to put it in and out, but we don't want to take the tool out we don't want to take the edge finder out, which is in tool position 1. We want to put a different tool in. So we have an empty space on slot 4 here. So what we're going to do is write a very small program that's going to put away our edge finder, and then go over and allow us to put in our 3/4 inch end mill. So to do that, we go back to MDI. The program that we're going to do is T for tool. 4 is the tool we're going to change to. Alter. And M6 for tool change. Alter. And now we'll run this, and it will put away the edge finder and try to load the empty tool. So now it's just a matter of putting our tool in that holder. All right, so now we got a tool in the holder, and it's time to set our work offset. So I jogged the tool down and over to where the tool height gauge is, and now I've set it to 1,000th increments, and I'm just gonna move the tool down until it hits the surface, and then you'll see the dial start counting up. There it is. So now the bottom of the tool is exactly 4 inches above our reference surface. So we go back to the machine now, we press offset, and we get back to the tool offset page, and you'll see it's highlighted that we have tool 4 in the machine, and I had cleared this. So what we want to do is go down to here and press tool offset measure. And so that gets us the measured distance from the bottom of the Z to the top of the tool measurer. But we're not concerned with the top of the tool measuring device. We want to know what the reference plane is relative to the bottom of the tool. So we have to subtract that 4-inch known distance. Now, if you had used the 1, 2, 3 and dowel method, then you would subtract the height of the dowel and the height of the 1, 2, 3 block. So in our case, 3.4. So what we'll do is we'll subtract 4.0, and you press enter. And so now it's a total of 9 inches from the bottom of the tool holder to the reference plane. And you can do a visual check there. I mean, if you look at here, between here and here, that's around 9 inches. So that's the distance that we're measuring here. Another thing you want to do while you're in this menu is you want to set your diameter for compensation. Often I use computer-based tool compensation, which is how big the tool is, so it knows where to move the center relative to the work. But it's always a good idea to keep it in here just so that when you go up here, you can kind of see which tools are in there. Just go over here to the geometry, and this is a 0.75 inch end mill. So do 0.75, and F1 will write it in there, and there it is, 0.75. Okay, so we have found our X and Y work offsets, and we found our tool offset. And the last thing we need to do is find the Z offset. Now the Z offset is a distance that's measured from your reference plane to the top of your work surface. And it's a negative dimension because it is applied to the tool offset for that particular operation. So in order to do that, we're going to use our height gauge. So let me remove this, jog this out of the way, and I'm going to clean up this whole surface here because we'll use our height gauge to find the Z offset. All right, so to find our Z offset, what we're going to need to do is we're going to need to measure the distance between here and here. And the easiest way that I found to do that is if you have a height indicator that can sit here and know it's 0 at the bottom of the height indicator, you can just sit that there and measure to here. The height indicator I have, at least as far as I know how to use it, does not go all the way to 0 at the bottom of the base. So I sit it here, set an absolute on the reference plane, and then when I dial it up to the work surface, I'll know exactly how to do that. So I'll put that in here now. Crank it up. Dial it down slowly. Don't force this because it will lift it up. So now when I press 0 on the back, you can't see it here. This is 0, 0, 0. Let me see if I can get the camera around here. So now I'm going to bring it up. You see there. And bring it back down till it just touches the top of my work. And typically this will be a flat work surface, or flat enough that you're going to mill it off, and you want to know the Z height there. So now it's 1.535 from the absolute that I had here to the top of my work. So that 1.35 negative is our Z offset. So again, press offset to get to your work offset. So we set these two with the edge finder earlier. Now this is the one that you're going to set based on that measurement you just took. 1.532, so we'll do negative 1.532, and F1, we'll write it in there. Now the last thing we're going to do once we've set all these parameters is actually load a program and run it. I put a floppy disk, you know, those 3.5-inch things that people use as coffee coasters these days. That's how I was able to load the program into this, so I put my program on that. The naming is tricky. We called it O30001.NC because the programming naming nomenclature was in that form. So right now there's a program in there. So in order to load the program, you go to list program. F3 is a disk read. So we'll type in the file name, which is O30001.NC. Press F3, and it's loading the program. It's done. And now if we go to memory, you'll see this is the program that I loaded. That 3/4 inch end mill used to be in tool 6. I switched it for the purposes of this demonstration. I did the same thing with a 1/2 inch end mill. I brought it down, I checked the height, and I set its offset. So we have different offsets for different tools, and the machine knows where to put that tool in relation to the program you're running. Before we start this machine up, there's a couple things that you'll want to know and be ready to do. Keep your hand on this just in case, because if you did something wrong in your program, you're going to want to stop it immediately. It's nice to have handle control in your feed rate, because if you set your feeds too high in the software, you can dial it down or up. You press that. Now it says feed 100%, and you can adjust the feed rate like that. Also, these rapid settings are pretty important, especially when you're starting out. This thing will fly around the table, and if you don't, if you're worried it might crash into something, you can set it to 5%, so you have time to react and shut it down. So I'm going to set it for this demonstration to 50% to 25% rapid, so we can see what's going on. And so that's basically it as far as getting the CNC machine set up. You make sure your tool height offsets are correct to the reference plane. You make sure your work offsets are correct in the X and Y, and that you measure the distance between your reference plane and the work height, the top of the workpiece for your Z offset. You make sure your tools are specified in the program correctly, and you know how to jog now. So now it's just a matter of running our little program. press cycle start, and you'll see the tool change and it start. Well, I hope you enjoyed this lesson on how to use the Haas VF-2. I know I wish I could have watched this video even with looking at my silly face, because it would have saved me a whole lot of time figuring things out by hand. I guess you could read the manual, but that's a lot of words and a lot of people prefer videos. So good luck with your part, and keep machining, never stop building, and remember to subscribe to the channel and check out my blog at neverstopbuilding.com. Thanks a lot.